Welcome, fans of pre-algebra, to another episode of Mr. Chow Time. Today, we're talking about constant rate of change and slope, which are basically two words for the same idea. So, what is the rate of change? Well, a rate of change is a ratio or rate. Remember what a rate is. It's a comparison between two numbers where, a rate is two different units, but actually it doesn't have to be two different units, although it can't be the same unit measuring the same thing. So it could be like height of boys and height of girls or something like that. So it can be two heights, but it can't be like height of 7th grade boys over height of 7th grade boys. So it's going to be a rate, which is a ratio comparing two things with different units, measuring two different things. And it's going to describe how they change compared to each other. In a linear relationship, the rate of change between the quantities is the same or constant. So, for example, one boy for every two girls, two boys for every four girls, three boys for every six girls. This is a constant rate of change. So as one quantity changes, the other quantity changes. It's a constant ratio. A constant rate of change is a relationship that is linear. So that's really basically another way of saying this. As the rate changes, for one variable, the other one changes in the same way. Okay, so let's take a look at some examples of that in action. The table shows the distance traveled on a zipline tour. A zipline tour, is one of those things with like some trees and there's like a line that goes between, and you dangle between the two lines and you go zip from one side to the other. Zip line. So this is the time, this is the distance that you've traveled. What is the constant rate of change? Well, you can see here this is plus 2, plus 2, plus 2, plus 2, plus 2. And here we have plus 12, plus 12, plus 12, plus 12, plus 12. So the rate of change is 2 seconds for every 12 meters. And we can reduce this to be 1 over 6. So this is our rate of change. All right, your turn. Welcome back. Here we're adding 1 each time, and on the bottom we're subtracting 20 each time, right? So it's 1 day for every negative $20 spent, right? I guess I'll put the $sign on the back. So this is negative 1 over 20. This is your constant rate of change. Okay. You can also use a graph to find the constant rate of change. So if you have a graph, you can look at any particular point, like this one right here. And a graph, remember, is just a visual representation of the relationship between two numbers, right? So here we have number of seconds, and here we have radius of a circle. So a circular design on an ad, perhaps a YouTube ad or something, has two circles. One that is decreasing in size and one that is increasing in size. So there's two circles. One is increasing in size, one that is decreasing in size. Find the constant rate of change for the radius of circle 1 in the graph shown. So circle 1 is right here. Circle 1 has 2 and 5. Right? Because this ordered pair here is 2, 5. And let's just talk about something right now as we are talking about rate of change. So the x-axis is typically going to be or it's not typically, it's always, if there is an independent and dependent variable, if there is one thing that depends on the other thing, the x is going to be the independent. And we're going to put that on the bottom, okay? The x on the bottom. And the y, if there is an independent and dependent relationship, the y is going to go on the top. So this is going to be x, which is 2. So actually this is not written correctly, right? X, which is 2, and y, which is 5. And yeah, so we'll just put that over here. X, y. So x is 2, y is 5. And then we're going to look further down on the line, and here we're going to see 6 and 4. 6 and 4. And once you have 2 points and you know that the graph is straight or a line or linear, so linear, remember from this slide, linear relationship has this word line in it, right? Right here, line. The rate of change is the same or constant. So anytime that you have a straight line, you know you have a linear relationship, you know that you have a constant rate of change. So you only need 2 points to be able to find the rate of change. So here you can see we're going to add 4, and here we're going to subtract 1, right? And that makes sense because this circle is getting smaller and smaller. So it would be -1 over 4. All right, your turn. Find the constant rate for the circle 2. So here we have 2, 3, and here we have 4, 6. So that's going to be 2, 3, 4, 6. So here we're going to add 2. Here we're going to add 3. So it's going to be 3 over 2, because remember it's going to be y over x. 3 over 2. Okie dokie. Here are some words that you should know. If the rate of change is said to be positive, that means that the graph is moving up when you're reading it from left to right. When it's negative, that means it's going to be moving down from left to right. And there's no change when it's flat. And there's one other case when it is vertical. If your graph is vertical like this, that has an undefined slope or undefined rate of change. And we can talk about that. Yeah, we can talk about that later. We don't need to talk about that right now. Okay. So slope is the ratio of the vertical change to the horizontal change of a line. So the vertical change is the change in y, right? So the vertical change is going to be on top in this ratio. And then the horizontal change, this red line right here, is going to be on the bottom. Again, this is y over x. So to find that, you can just take the y values and subtract the x values, which is what they're showing you here. All you need to do is just define for yourself which is going to be the first point and which is going to be the second point. It doesn't matter which is which. It doesn't, because it just isn't going to matter. So here, they're taking this to be the first point, point number 1. And you can see here is x1 and here's y1, right? And this is going to be point number 2. You can see here x2 and y2, right? So you take y2 and you subtract y1. So here's y2, and then you subtract y1. And then you take x2 and you subtract x1, where x2 and x1 cannot be the same, right? It cannot be a vertical line. This is a situation where the line is vertical because the x values would be the same, right? This is called the slope. This is the formula for slope of a line. And so let's practice using that. So let's say we have here this line. I'll just rewrite our formula right here, y2 minus y1 over x2 minus x1. Remember, we can name whatever we want. It doesn't really matter, but the way that I'm just used to doing it is just to go from left to right. So this will be point number 1, and this will be point number 2. Now you could do it the other way. It's not going to matter. So this is the y value for y2. So that'll be 6. And this is the y value for point y1. So that's going to be 3 over 8 minus 4. So this is going to equal 3 over 4. That's our slope, or rate of change, which is what we were finding earlier. Here, again, I'll just name this one 1 and this one 2. So this is 2. This is negative 2 minus 2 over 2 minus a negative 4. And so remember that if you're subtracting a negative, that's going to mean it's positive, right? Or it's going to mean it's addition. So negative 2 minus 2 is going to be negative 4. And then 2 minus a negative 4, which essentially means plus, is 2 plus 4, which is 6. So that's negative 4 over 6. So we're going to reduce that to negative 2 over 3, because we can divide both of these by 2, right? Which is the greatest common factor. So negative 2 over 3. All right. I'll bet you there's a your turn coming up. So predictable. All right. Have at it. Welcome back. So this is negative 3. And I'll even do this one opposite, just so you can see that it doesn't really even matter. Negative 3 minus 2 and negative 5 minus negative 2 equals negative 5 over, this is negative 5 plus 2, so that's negative 3. So it's negative on top and negative on bottom. So those are going to cancel out, and that's going to be 5 over 3. All right. So let's say I don't even give you a graph. I just tell you that there's points A and B, and they have these coordinates. Your turn. Welcome back. So we'll just call this one 1 and this one 2. So it's going to be 2 minus 3 over 1 minus negative 4. So that's going to be negative 1 over 5. Great. Moving right along. Find the slope of each line. So here are some crazy examples, right? Because this one is a horizontal line, which means that if we took the 4 and we subtract a 4, we're going to get 0, right? And then it doesn't really even matter what's on the bottom, but we'll just do it anyway, just because, why not? We can always do the extra practice. 5 minus a negative 3 is 5. So anything with a 0 on top is just going to be 0. So here the slope is 0. And here is that other case that we were talking about, a vertical line. So we have 3 minus 0, which is 3. And then on the bottom, we have 1 minus 1, which is 0, right? So this equals 3 over 0. Now you cannot divide anything by 0, because dividing, remember, is splitting up a total, which is the top number, into groups of this size, right? So if I have 10 students and I want to put them up into pairs, I want to split them up into groups of 2, well, I would have 5 groups, right? And each of the 5 groups, would have 2 people in it. Well, if I had 3 students and I put them into groups of 0, that's not going to be anything, right? So this is undefined. Okay, and that is different from 0. These are not the same answer. And they will, clearly not be the same answer in any situation, including a test. So be sure that if you have a horizontal line, the slope is 0. On a vertical line, it's undefined. Okay. So your turn. What is this one going to be? Well, you can see that the y's are the same, right? The y's are the same, so it's going to be 7 minus 7. So the top number is going to be 0. The bottom number doesn't really matter what it is, but we'll just do it anyway. 5 minus negative 1 is 6. So our slope here is 0. Your turn, number 2. Find the slope. Welcome back. So here we have negative 1 minus 4, which is negative 5. And then we have 2 minus 2, which is 0. And anything divided by 0 is undefined. Okay. Great. Here's your must-do, 399 to 401 odd. Good luck and goodbye. Where's my mouse?